So this
Okay.
meeting is recorded, and we are following the CNCF code of conduct during this meeting.
Yes. Okay. So welcome to the Prometheus storage working group. We had a topic from last time, but unfortunately, whoever put that in the meeting notes from last time doesn't seem to be here. So let's go on with Jan and Damien's topic. Go ahead.
Yeah, thanks, guys.
So, do you want to go ahead, Jan, or should I start?
Sure. I'll just outline the problem real quick, and Damien has done more research into the possible solutions. So the issue we are trying to solve is one that we see regularly in OpenShift deployments. On upgrades, we have quite a bit of series churn. So we get a lot of new series and the old ones are no longer used, which blows up the memory and in many cases leads to out of memory kind of loops. So Prometheus tries to start again, reads the wall, memory blows up again, and that repeats indefinitely without intervention. So we started looking into possible solutions, and we are not very far along with this yet because we basically found a lot of old discussions that kind of touch on this subject, which are sort of similar. Often the discussions were dropped at some point, or it's quite possible we also don't see that we can have a solution for this already. Basically, the avenue we kind of want to explore is essentially a wall flush, or that's how it started out. So we figured, with this memory blowing up, it would be nice if we could just shut down Prometheus for a few minutes, do sort of this wall flush, whatever that might be in the end, and then start with a fresh wall, not hundreds of gigabytes of memory, and proceed with the upgrade of the Kubernetes cluster. Right, and as I said, we're very early on in actually looking into what's going on and how this could be solved. We just thought we bring this here early because of the existing discussions. Some of you might already go like, oh God, not this again, or others might go like, well, this is a solved problem. I think or maybe Damien, you want to take over with where we are currently?
Yeah, definitely. So the first thing we looked into, as Jan said, was basically flushing the wall manually, or at least have a mechanism to do that in order to kind of free some memory before the upgrade. We also looked at a recent addition that Ganesh was pushing upstream with snapshotting. But in our case, the issue is that the churn that we are seeing is mostly in the head already. Like in OpenShift, what we see basically is that around 2 times the number of series that we've had before the upgrade, like there is 2 times the number of series after the upgrade. So basically all the memory consumption is in the head, and it's already quite a lot of memory there. So even with snapshotting, where we won't have to go through the whole wall during the replay, there will still be too many data into memory. So the kind of tool direction that we've seen was to kind of have a mechanism in Prometheus that would kind of detect this sudden increase of cardinality and maybe activate some kind of flush there. We haven't yet really looked at how this could be possible, but the goal would be for Prometheus to, in case something wrong will happen with memory, like we know the consumption is too high, then we flush the memory to disk, or everything that is in memory to disk. And the more recent thing that we've looked into is also that after a couple of tests with, we've tried launching a service that would, after each scrape, create new series to see what would be the changes on TSDB. And what we've seen is that each series will create a new chunk, will result in a new chunk, and these chunks that became stale because there is no new samples for them are not getting cleaned up. So that's another thing that we looked into, is that even after the upgrade, basically Prometheus will keep all the data from the previous version of the cluster. And so we've kind of figured out that maybe the issue is not really in the increase of cardinality, but maybe more into the retention of this stale chunk that we keep after the upgrade. But we've not looked yet deep enough to see if there is actual mechanism yet to get rid of these chunks or not. But yeah, these are kind of the two directions that we've seen so far. Maybe you could find a bit more for us or even enlighten us.
So I think there are a couple of things happening at the same time here. If I understand correctly, your Prometheus server is essentially running and ooming because of the churn, or is it restarting because of the upgrade itself as well, and then ooming because it's replaying the WoW? Because there are kind of multiple problems here, right? Like we already know, and I think 2 or 3 sessions ago we were talking about that replaying the WoW should actually be a constant memory. That's definitely a problem that basically, quote unquote, just needs fixing. And then I think what you were saying about like essentially flushing stale chunks is actually something I don't think we have an issue for, but it sounds reasonable to me. Basically, we already have this mechanism where when we have a complete chunk, we flush it to disk, but I see no reason why we wouldn't do the same for an incomplete but stale chunk, and then essentially start a new one should this series start again, which seems really unlikely for if the latest sample is stale. Yeah.
So I think we see this memory blow up. Damien, correct me if I'm wrong. Also, just on normal upgrades without Prometheus restarting. And then, of course, this is a kind of positive feedback loop when you OOM and then wall replay with the new metrics kind of makes it grow quite fast.
Yeah, I guess you need. Yeah, I mean, the well replay kind of amplifies the problem, right? But you still have the original problem, and that's a really difficult situation because, and we've talked about this at the very beginning when we started this working group. Essentially, we need some sort of mechanism to offload the index from memory in the write-ahead log. As you already said, the chunks are one part, but actually the metadata, the index, is actually the thing that's much more expensive in the head block. So while what you said about flushing chunks is going to be important as well, I think getting the index to external memory is going to have far bigger impact for you.
Yeah, exactly. And that's why we talked about maybe temporary small block flash, right? Like flash the whole database into the block, which is maybe 10 minutes or half an hour, which should be fine as long as those are rare situations, because it will be compacted into bigger one, right? And I know we have lots of experimentations with super short blocks that always no one actually could work out in the long term. And this is because people were trying to build those 10 minutes block or 5 minutes, something ridiculous like continuously. But if, from time to time we have like half an hour block or 20 minutes block or even 5 minutes block, then it doesn't matter in the long run. So that might be something, some failover mechanism.
So I think the difficulty that you'll have here is that you have no atomicity here, right? Like how do you know whether now is the right time to actually flush, right? Sure, when an upgrade is starting, but like the upgrade can take half an hour or maybe even 2 hours, multiple hours, right? It depends on the size of the cluster. So I don't think you'll actually win a whole lot by flushing often. I don't think it's really going to help.
That makes sense to me. I don't think that the solution is to flush often. It will be only flush, in 2-hour periods like we have right now, or if we are close to the time to the memory limit, and then you flush once, right? It doesn't matter if the upgrade will go further and be like week long or 1 hour long, because at the end we'll start to build up from scratch, so we have lots of room, right? That's kind of the idea.
So correct me if I'm wrong, but I think we have an admin API where you can trigger flushes.
No.
We talked about that, but we didn't even
discuss. Yeah.
Okay. So I think I would be okay with adding like an experimental flag to have such an API so that you can experiment with this. I personally am not convinced that you'll actually fix your problem with this, but I'm open to exploring it through that. That's just how I think about it. Like doing an experiment and getting some data is far better of an argument than I don't know, discussing here, right? I still think the like getting the index onto external memory is ultimately what's going to solve this problem for you, because essentially what you can then do is that you can have a size limit and not a time limit or anything or something like that, where you every time you reach, I don't know, 1 gigabyte of memory, you flush it to disk and map it into memory. And that way you kind of can never the worst that you can get is a performance penalty for like evicting and loading things from and to memory.
Yeah, I think the original idea was to implement such a limit based on the number of series that are currently in the head block. But I agree that, well, by now that does seem to maybe just at best be a workaround, which honestly it was kind of intended to be from the start. But with this issue of stale series in the head chunk, I agree that this also seems like a thing that would solve this neatly. What I conceptually still don't really see is how an API would look like for this, because we'd essentially, or it would be good to have a way of telling the TSDB, okay, these series are now stale, get rid of them, right? Instead of, I'm not sure we can do this automagically and not introduce some corner cases that makes it awful for some users again.
I mean, the TSDB already does kind of plenty of housekeeping, just like flushing the chunks to disk, like the full chunks to disk right now. I don't see why having this kind of housekeeping check whether the last sample is 5 minutes ago, which is our typical automatic staleness window. If no new sample has been appended within the last 5 minutes, that we'd just flush the chunk to disk and start a new one. If I think, Julian, you want to say something?
Yeah, you have to think that we also promise that you can backfill 1 hour in the past in the TSDB. That's what we guarantee, that you can still insert data from 1 hour in the past.
And does that imply that, or can you only backfill to things that are in the head chunk?
Yeah, so you cannot backfill to blocks, you can backfill in the head. Basically, it's done by just exposing matrix with a lower interval. If you are lucky, I think you can even backfill 2 or 3 hours, but I think we only guarantee 1 hour.
Yeah, right. But like, it doesn't make any difference, right? We already have a corner cases where we kind of we have a stale marker or whatever for some series, and then in 15 seconds later the same series just reappear. That's kind of the same when you are backfilling. You have this risk, and I think there are ways to mitigate this risk. For example, start a new chunk, and then when you are flashing into the block, you can compact those together into 120 chunks, for example. I think we already split those thanks to I think Matthias PR or something. So we could maybe mitigate those risks. I don't know.
So yeah, the issue I can see is that users could have like out of order samples. That kind of things might appear if we like flush too early. That kind of things. So we need to know what's in the head to prevent people to insert in the wrong order in the TSDB, because we don't support that yet.
I don't really see a new issue about that. And the rest seems solvable to me. Like a chunk could be stale based on the last time it has received a write, as opposed to the last sample that it stores. Like, I don't know, the overhead of this kind of metadata could be too much as well, that it ends up being unreasonable. But I think it's worth the experiment. And just to be clear, when I say flush the chunks, I mean the same thing that we do with full chunks right now, not the entire head to block. I just mean the chunk to disk, and then I map that chunk, which Ganesh implemented like half a year ago or so.
Exactly. Yeah.
Okay.
So yeah, I think this is worth experimenting with. But yeah, the general problem you'll still have of the index being in memory, and honestly, I think this is what's hurting you most, as opposed to the chunks. Like we know that like roughly the ratio is like each series has overhead of what's worth 1,000 samples. So creating a new series is by far more expensive than creating a new chunk.
Gotcha. And is there an existing issue for this index overhead? I can, if you say yes, I can just go and find it.
I don't think so. I think that's mostly what we started this working group for.
Gotcha. Cool. Yeah, I mean, this is super helpful. We'll definitely look into that part as well. As I said, we're super early in actually looking at this. But yeah, it's good to know that this group at least sees this as worth pursuing, and I think we got some good input here too.
I want to say fixing the while replay is gonna help a lot for you, because it just means that you could increase the resources and it'll work, right? Just as a workaround. Whereas right now the replaying the while spikes so hard that sometimes, like, even we've had this problem that you just need to trash the entire database to get a working server again, just because your server's limits are being reached.
Yep.
So do we have the wall reply issue then? Let's structure this. I think we have index in memory, external memory for index, then the wall reply work, and flashing chunks, stale chunks. Those three would be nice to cover. Maybe the flashing, but this is maybe like a mitigation number last. Let's create those. I don't think any of this is.
I know the while replay stuff exists,
right.
And I'm trying to find it in our previous notes, because I know that I've talked to Ganesh about this pretty recently. Maybe Matthias, did you start investigating this at some point?
I don't think so. I worked on fixing like the 120 samples thing and a bunch of other stuff, but yeah, it didn't went into that direction.
Oh no, sorry, this is a PR.
No, this was on 20th of April, and Ganesh said that he hasn't had a chance to profile this yet.
Well, my only worry is that any wall reply improvement will kind of balance the time, which is already long, right?
There's no reason, though, why this wouldn't be possible to be in constant time. Constant memory. And then it's up to the user to configure how much they want to dedicate to replaying.
Mm-hmm.
So I have linked the issue about the wall replay memory usage.
And beyond that, while replaying should be a CPU bound thing, not a memory bound thing.
Cool.
Yeah, very cool.
Yeah, I started making the HTTP endpoint for Comprov itself available so that we could observe wall replay there, but we didn't merge it yet. So I think that's kind of blocking us on that side. And then we can have wall replay perf analysis for both Prometheus and Comprov and go deeper on what's the actual problem.
So I spoke to Ganesh yesterday, the contributor hour, and we did speak about this, and he told me that he will have time in the coming weeks to look at that probably.
Amazing.
Okay, cool. I know that anyone using TSCB has this problem. So Cortex is suffering pretty badly with this as well. I know I've talked to Ganesh and Marco about this.
Well, I was surprised because Ganesh told me some numbers which are way higher than what I see with my Prometheus in production. Like, he told me it can be multiple times the memory usage.
Yeah, because
that's what I'm seeing as well.
But
yeah.
My Prometheus is not over-provisioned by 2 in the RAM, so I am really wondering what's going on.
Well, they have thousands of these DBs, right? So you multiply essentially.
Is that? But that sounds like it could be a per TSCB overhead then, right? Why it's amplified in Cortex and Tanos?
In my opinion, yeah.
But still, like I think what Damien and Jan are investigating is single Prometheus servers, right? So single TSCP.
Yeah.
But I've definitely seen this problem in single Prometheuses as well. So yeah, it's definitely the most important thing to investigate, I think, and it's the one where you're going to have the biggest win because at least it opens up a workaround. And then after that, if you find a simple way to flush the chunks, that's definitely something that should be done as well. But flushing the index is going to have far bigger impact. But the flushing the index is going to be quite a lot of work because essentially you need to build a new data structure for the index that you can efficiently merge. Yeah.
Okay.
Yeah, we've done plenty of like previous research which we can share, but there's nothing definitive that we've found or implemented.
Yeah, can we maybe split those things to be kind of put into issues so we don't lost the status? Maybe I don't know. I can write the issue about the wall chunks flash with I don't know, Damien and Jan, and looks like you can nicely elaborate, Frederick, on the index in external memory flash. acceptance criteria. Essentially, that's it. Well, that's what would be nice to have, I guess.
I mean, I can open an issue. I don't think how useful it'll be, because most of it has been researched so far. So it's like head index using too much memory.
It will be, right, but like the way how we already think about the solution, and it's already helpful and might trigger contributor to research as well. So
that's fair. Yeah, just assign me to it, and I can try to open something useful. I have to run, but I think this was a good discussion. Thanks, everyone.
Thank you.
See you next time.
Thanks a lot.
Bye.
Thanks a lot.
Bye.